Hey everybody, welcome to Astronomy Daily Live for the 7th of July, 20, 20 2018. Is it 2018? Yeah, it's 2018. Yeah, so hey everybody, come on in. Come on in, join the circle. Glad to be back. Yeah, yesterday was a little bit of a surprise. We've been having some problems with our server at work, and I'm the system administrator. So guess who has to deal with computer problems? Yeah, you're looking at them. So yeah, I had to deal with that. That was sort of the end of a fairly long process. Our server got severely um, attacked uh, to steal CPU cycles. And at least one of the things that this attack did was and let me or let me reveal the chat here. Hey there. So the attack randomly deleted system files, um, executables associated with various services and whatnot. So things just started shutting down because there wasn't an executable there to run. you know, the service is like, okay, I need to run this executable, right? And so it goes out onto the system and attempts to retrieve that file, and that file is gone. It's just not there. So it's like, oh well. So yeah, we had to ended up having to completely rebuild the server, actually upgrade it, and but yeah, it looks like pretty much almost everything is working now. And yesterday was just it was sort of the end of that uh, long process. So I wanted to have it done, and by the time I looked at the clock, it was like 125 UTC, and I'm like, this ain't happening today. Nope, not happening today. So yeah, that's why it was canceled. That those kinds of things happen. As I say, I mean my thing here is to be very consistent, very consistent, because for the most part, at least at this particular uh, span in time since I've been doing this live stream. Um, yeah, this time of day, starting to wind down, thinking about astronomical things anyway. So why not share it and find also those like-minded individuals who this is a different angle, I think, than most of at least the astronomical um, YouTube channel podcast type of things. I think this is a little different because I honestly I do not have anything really planned, um, uh, and I find that there's enough material in almost the simplest of things to be able to easily cover an hour uh, or so. Usually a little bit more than an hour, but that's just what happens. That's just what happens. I do greatly appreciate you all spending your time here. I think that's very cool, and I I am definitely looking for a growing crowd. Um, just because I know that there is. I don't really have any kind of um, um, aspirations or anything. I'm just here to, share the passion and have fun and, just sort of chill and, relax and talk about a thing that I think is like the coolest thing ever. So cheers. It is hydrogen hydroxide again tonight. Cheers. So Atta, congratulations on your purchase. I think that's a really 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 big step. But if you need any kind of support whatsoever, feel free to get a hold of me. Um, uh, I've got an email. It's cosmiclettuce at gmail.com. I've got something in my tooth. Yeah. Okay. Excuse me about that. So cosmiclettuce at gmail.com. And, I would say, um, really to get questions answered um, when they pop up, go to Cloudy Nights and post your question there. Send me the question too, right? But it's probably going to take me a little while to respond. The Cloudy Nights folks love new people, and they love questions. They are ravenous question eaters. They love questions because they come back with answers, um, usually very rapidly and at high volume. So I mean, I guess it sort of depends on the question, but I would say go there first. Um, you know, and feel free, to send me a message too if you want, or put it up on Discord, whatever. However however most comfortable you feel about communication is fine with me. And if uh, if you don't think that's a question I'd be able to help you with, don't ask somebody else, right? Because I certainly do not know um, all things. But yeah, yeah. So hope that goes well. Hope that goes well. And yeah, I I'm I'm not saying that I should be last resort either. I'm just saying that if you want a relatively timely response, in an hour or two, Cloudy Nights is probably your best bet. Um, you know, with me, I don't know, right? I mean, it could be 12 hours, it could be 24 hours. Probably not anything longer than 24. I don't think so. But it might be right away. It sort of depends on what's going on around me. So, but cheers. Yeah, I think I think you have a lot of toys there, and I think uh, you know if you have the right attitude, I think you're going to have a lot of fun. So, you know, if you're mechanically inclined at all and sort of get that kind of stuff, then you're not going to have any problem at all. So, yeah, cool. There's a little bit of assembly required. When you get the scope, you'll get I don't know how many boxes. I don't know, two big boxes, and then inside each one, there's a bunch of smaller ones, something like that. I forget exactly how mine came. I think that's right though. But yeah, lots of boxes, lots of pieces. But it's they've made it really 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 easy, and you know uh, you might get something on backwards or upside down or something, but it's like, oh well, you know. I mean, things are pretty forgiving, and these things are designed uh, to be pretty foolproof, right? So you can be an idiot and be able to put these things together apparently. so yeah. Yeah, okay. Yeah, yeah. It looks like a moron can assemble it. So you're going to have to, you know, turn on your moronic uh, brainwaves so you can become a moron so you can figure this thing out. Because that's actually an interesting point. It's really, really, really easy to overthink things, right? Instead of looking at the instructions that say, put screw A into hole B, right? You overthink, and it's like, yeah, but there's two hole B's, and this uh, screw A doesn't look like the picture, all that. But so yeah, you just have to just sort of blindly, dumbly do things according to the instructions. And as I said, if you run into any kind of trouble at all, feel free to call on me, no problem. And Cloudy Nights is a good source too. So because yeah, I mean you're jumping into the deep end, so you've got to. I hope you're wearing your life preserver. It's probably not going to be that bad. If you're determined, you won't have a problem at all. Yeah. All right. Well, cool. So the one thing that I wasn't able to do yesterday that I wanted to was wish you all a very 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 happy Aphelion at 17 hours UTC on the 6th, which was let's see, I want to say 17:07. That was about 9 hours ago or so. About 9 hours ago, the Earth was at its furthest point from the sun. So that happened just a few hours ago, 9 hours ago or so, 9 hours and 14 minutes ago. So uh, uh, yeah, that's a pretty exciting time as well. And that, again, is one of these shared experiences that all of humanity uh, experiences, whether they know it or not, right? Whether everybody knew it or not, right? And 99.999% of the population doesn't know, doesn't care, right? Doesn't know, doesn't care. But for those of us who do and think it's very very cool to contemplate that, right? To think about that we're as far away from the sun as we're going to be for another year or so, for another 12 months or so. Uh, we're not going to be this far away as we are right now, and that 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 forces me at least to think a little big, right? To think a little bit big, and find my place in that, my position, my circumstance, and in fact all of ours, right? Uh, yeah, I mean our situation is uh, mind bending. It's absolutely incredible. Uh, the what our circumstance is right now as we speak. Um, so yeah, to think about how um, that we're at that point in our orbit around this star that we are furthest away. And yeah, isn't that an interesting an interesting thing that you know, people in the northern hemisphere um, are saying, now wait a minute. If we're furthest away from the sun, shouldn't we be colder than when we're closer? And the answer is, well, yes, that is true. That is actually true, right? The it uh, uh, the, the density of light, which we sort of interpret as luminosity or brightness, but right, but the density of light falls off as the inverse distance squared, right? So the amount of light at a given point, right, from say a star, right, is a certain amount, right? So if you double that distance, you cut in by 1/4, 2 squared, um, the density of light, or how bright the object is. Um, where was I going with that? Oh man, it's one of those nights. I'm going to start up my smartphone here. Yeah, I think I'm just getting old because for some reason I completely lost my train of thought there. I wanted to talk about oh yeah, I'm just getting old and senile. Old and senile. Can't remember what I was gonna was talking about. Dang. Yeah, that's pretty bad. Cheers. So I think I'll tell you a short story. Yeah, watch it, kid. So I'm going to tell you a little story about when I measured the velocity of light, and there's really only one part that I don't quite remember. Now I'm gonna give you a little bit of backstory as well. This was um, I took a physics laboratory course. It was physics 480. Physics 480. Um, Sort of, you know, the highest level lab physics that an undergraduate can take. This was like, you know, the advanced lab, and what we did is we did the fundamental experiments. I actually have a pretty cool book. It's up here, probably a little dusty, but here. So it's called Great Experiments in Physics, from uh, firsthand accounts from Galileo to Einstein. And there's the editor, at least. So this book might have been revised by now, but um, this book goes through, you know, some of the great um, physics experiments that were done. Right? There's accelerated motion by Galileo. There's Boyle's law. There's the laws of motion. Um, the law, the laws of the laws of electric and magnetic force, the law of gravitation, um, Cavendish, some kind of a Cavendish experiment, the interference of light, the diffraction of light, electromagnetism, um, Michael Faraday's experiment with electromagnetic induction and the laws of electrolysis, Lenz's law, the mechanical equivalent of heat, James Joule, electromagnetic waves, Heinrich Hertz, X-rays, natural radioactivity, the electron, J.J. Thomson, the photoelectric effect, Albert Einstein. I don't know if you all know this or not. Maybe this is unknown to you, but Albert Einstein did not win the Nobel Prize for relativity. Relativity never got the Nobel Prize. Think. But Albert Einstein got the Nobel Prize for the photoelectric effect, and that is, given certain circumstances, you can convert the energy contained in a photon of light into the energy that moves an electron, and that's electricity. So he discovered that and got the Nobel Prize for that. As far as I know, I don't think. That's what I was talking about. Yeah. Okay. Um, anyway, so yeah, some great experiments in here. Now, Tom was kind enough to remind me what I was talking about before. So let me backtrack and get into that a little bit more. So right. So as you move away from an object, the less light you're going to feel. So it's absolutely true that we experience more intense radiation from the sun at perihelion than we do at aphelion. And it's aphelion, it's not aphelion, it's aphelion, as far as I know. Um, uh, so, um, yeah, there's. I looked it up too, Tom. It's it was 5 million kilometer difference, 5 million kilometers. So, if I'm gonna. Oh, where is it? Oh, where is it? Hey, where did it go? Oh, there it is, behind the laptop. Every good scientist has their calculator within arm's reach. Now that technically that was within arm's reach, right? I just had to reach around the laptop here. So, but I didn't see it, and for a few moments there was a lot of just sheer panic. Uh, anyway, there it is. So let's see. I think it goes between 147 and 152 million kilometers. So 147 plus 152 divided by 2 is 149.5, and 5 million kilometers of that is 3.3%. So there's a 3.3% difference in brightness between aphelion, where we are now, and perihelion, which happens around January 4th or January 6th. So no, Tom, this is This is the same. This is the same one. It's the same one. It came, the fourth digit came back to life. So it is with me. Now, I still have my slide rule right here also. So, you know, if necessary, I will pull out the old slide rule. But definitely my go-to is this dude. So, yay. That happened before. It's really strange. That happened before, and it came back. So that's very cool. Anyway, so yeah, it's a 3% change. Um, so um, yeah, it's not a lot of a difference, right? It's not a lot of a difference. What makes the biggest difference is, of course, the tilt of the Earth. The tilt of the Earth is at 23 and a half degrees, and the how high the sun is in the sky, um, um, that determines by far how much radiation is landing on, you know, a particular area. Um, so the higher the sun is in the sky, more radiation, right, is hitting that portion of the planet. Um, and so, you know, one of the consequences of that is that it heats up. It heats up because there's a lot of energy being pumped into the surface of the Earth, and the surface of the Earth is absorbing that visible light, reflecting a little bit of it, right? And that's what we see is the ground and the flowers and the trees and everything else. Um, but a lot of that is actually being re-radiated as infrared. So it just, you know, I mean, the sun, of course, warms up the ground and the air, and yeah, the higher the sun is in the sky, the more light there is. There's just more of it, and with more of it, it just gets hotter. So even though, or you know, despite the fact that here in the northern hemisphere, we're the furthest away from the sun that we're going to be, the fact that we are tilted towards the sun, right, and the sun is really high right now, means that we are experiencing summer, and the southern hemisphere is experiencing the opposite. It's experiencing winter. So and I mentioned this over on the Discord server as well. My guess is that the southern hemisphere does probably experience more intense summers and more intense winters, little hotter summers, because during their summer the Earth is at perihelion, so it's as close to the sun as it's going to get, and it's going to get a little tiny bit more um, radiation because we're a little tiny bit closer. Um, uh, so yeah, I that's my guess. That's my guess. Um, I haven't heard anything about that. So if anybody can confirm that, anybody who's watching who may live in, you know, like Argentina, southern Chile, maybe even Uruguay or Paraguay, um, but pretty far south, um, so you can really get an idea, or anybody over in Australia, right? Or the South Pacific. Indonesia is a little too equatorial, so you know you got to be way south of that. But yeah, I'd like to find that out because that's yeah, I've always wondered about that. Yeah, yeah. It looks like it's what about plus or minus 1.65%, if my numbers are right. So yeah, plus or minus 1.65%. All right. So back to the story about speed of light. So this class, uh, as I said, was and probably still is called Physics 480, and it's a physics lab class. And so one of the first things that we had to do was we had to pick a partner. So they wanted us to have one partner. So I think probably just because it's most efficient that way. I mean, they've been doing this class for like 100 billion years. So I mean, they've got it down really, really well, right? Um, uh, so um, so what this was, okay, it 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 was a series of experiments, and we could choose. And I think for this semester, if I remember right, I think we had to do five. I think we had to do five experiments during the semester, and we could go as fast or as slow as we wanted, as far as I can recall. Yeah, I'm pretty sure. Um, so I think we had to do five experiments, and I hooked up with a dude who, uh, well, we both had a problem, right? We both had just one problem with this lab class. Um, that one problem was different for each of us. Um, the problem I had, the problem that I had was that I was and am pretty weak with the maths. Um, I can battle my way through, um, but if somebody knows what they're doing, it's done, right? So I wasn't very good at maths. What I was good at was setting up the experiment, setting up all the all the hardware, uh, you know, getting things aligned, you know, thinking it out, right? Now, my partner was uh, was his problem was that he had no idea how to set up experiments. He had not a clue, right? Not a clue. He couldn't even fathom being able to do that. But he was very, very, very good at math. Math came like super easy to him, right? I mean, to the point that he could not understand why nobody could um, could understand uh, mathematics, because it was just so easy to him, right? So as a team, right, we had somebody who was really, really good at setting up the experiments and collecting the data, right? And well, I'll get to the next thing. And my partner was very, very, very good at math, which we needed, right? We needed because we had to. Uh, so these experiments um, uh, were the the instructions sometimes were very uh, simple and straight to the point. And um, so the one that I like to talk about is the measurement of the speed of light, because that was I guess that was probably the funnest one. I also did the Millikan oil drop experiment, and that was very cool. That was very, very cool. I did not expect to see quantized charges. I was blown away when I saw that. It's like, wow, wow, that's really happening. So yeah, but that's a different story. So the measurement of the velocity of light, I believe, I can't be certain, but I think there were just a couple instructions saying something like measure the velocity of light with rotating mirrors and a ruler. And the cool thing is that this lab, being in this lab, right, we had access to anything that we thought that we needed in order to do the experiment, right? And I mean, as I said, this was a very, very old class. It had been going on for thousands of years, right? Um, uh, um, just looking at the chat. Yes, Totterbert, that is correct. At least that's one of them. That's at least one of them. Yeah, yeah. I've got I carry around a few. So yeah, yeah. It's there are given names and there are taken names, and I've got one given name, and that's the one in the chat, and then I've got a few taken names, right? Like cosmic, right? I mean that's a designation, but yeah, I think that's unique and interesting, and so that's that's what at least at least this name is for this live stream. So, but you may call me any of the above, no problem, no problem. All right, so yeah, measure the velocity of light with a rotating mirror and a ruler, and so we had access to any of the equipment in the physics lab, uh, and there was lots of stuff, right? Lots of stuff. So one of our first tasks, right, w- is to figure out, okay, given what we're told that we need, how do we go about measuring the velocity of light, right? And so we have a week and a half, um, yeah, maybe a week and a half or 2 weeks or so, to set the experiment up, um, collect the data, do the analysis. We had to, at the end of our experiments, we had to present our uh, our results to the entire class. So we had to create a presentation, an overhead projector. Do you remember the transparencies? Yeah, yeah. We had to do all of that, and give a presentation, right? I mean, I had to give one with one experiment, and my partner had to give one with a second experiment. So we didn't have to present every experiment. We just had to present two of them, as far as I recall. As far as I recall, I I did a report on Millikan, um, and I don't remember which one my partner did. We we also tried to measure the I think the electron proton ratio. I think we did that one. I'm trying to. Oh, we did something with with spectra. Remember that? Something with spectra, and then there was another one. There was another one too. I don't remember, but so yeah. Uh, so what you do to measure the velocity of light with a rotating mirror and uh, a ruler is you need a few more parts, right? You need a few more parts. You need a laser, and you need a flat mirror. You need the rotating mirror. You need a some kind of a like a sandblasted glass, so that you can see a laser spot on it, right? And then the ruler is used on that like sandblasted glass. And so what you do is you set up a a uh, a rotating mirror, right? A rotating mirror, and right next to it, um, you set up your laser, right? Now, I'm trying to remember. Yeah, I'm trying to remember the details. I think, yeah. So the I think this is how it went. The You shoot the laser into the rotating mirror, right? And at the other end of the room, as far away as you can get, you set up a flat mirror, right? So when you shoot the the laser beam into the rotating mirror, right? It's it's going to send that laser beam in sort of like a circle, right? All the way around the room, right? But when it reflects that beam onto that mirror, then that beam's going to be reflected back, straight back, right? Exactly back, right, to where it was. But, but in the amount of time that it takes for that beam to go from the rotating mirror to the flat mirror and back, that mirror has rotated just a little bit, right? Just a little bit. But there's no getting around the fact that it has moved. It has moved. And that causes a deflection, right, of of the beam, right? It causes um, this kind of thing, right? So the beam's coming in, it goes out, it goes back, and then gets bounced off this way. I think it's this way. Is it this way or this way? I think it's this way. And the amount of deflection, right? The amount of deflection is a function of the the um, the frequency of the rotating mirror, so how fast it's rotating, and the distance that the light travels. So as you make the mirror spin faster, right? We've got a little like a potentiometer on there to either you know stop the mirror from rotating at all. And by the way, this mirror is another flat mirror. It's a flat mirror that is just rotating, and you can change the frequency of that rotation. I forget exactly what it was, um, but and that's where my partner, the mathematician, would get in there, and he'd work out all the math. It's like, well, and he'd have it all done, and so he'd work out the math, right? Which I I probably could do, but under extreme, like, pulling my hair out. Um, uh, and so while he was doing the math, I would set up the experiment, and I'd show him what I was doing, and he would do exactly the same back, right? He would show me, you know, all the math, right? And he would explain it, and because I would always ask him things, it's like I don't get that. So he was extremely patient with me, and I was extremely patient with him because he did not understand experimental setup at all. I mean, nothing, nothing at all. Um, yeah, I mean, he was worse at experimental setup than I was at math, for sure, for sure. So, but as a team, we were great. We were really, really great because he could work out all the theory and then explain it, and I could work out all the experiment and explain it. And so, we both benefited. It was definitely a synergistic experience. Cheers. And I'm happy to say that in the end, we did measure the velocity of light to within, I think 1 or 2% or so of what it's supposed to be, right? Um, there there are stories, and I haven't really confirmed these. I've seen um, some representations of data, but I don't know if it's actual data or if it's just made up. I don't know. But my understanding is that um, when measurements of the velocity of light were made, there seemed to be changes. There seemed to be changes, and so somebody didn't like that. And back in 1972, 1976, the speed of light was decreed to be a certain number. Um, and you know, regardless regardless of what the the measurements showed, it was just said that the velocity of light is constant and it is this number. And I've I've just heard stories about um, the fact that measurements of the speed of light showed that it was changing, that it did change over pretty short periods of time, too, um, and changed in significant ways, right? It didn't change in the noise, right? I mean, it changed in significant ways that wow, I would think one would want to investigate. I mean, that makes me extremely curious. It actually makes me want to set up a speed of light measurement experiment, and make a measurement like every month or so. I mean, it's super easy to do. It's really, really easy to do. You just have to measure an offset. It's easy. It's really, really, really easy. And actually, the longer that distance between the rotating mirror and the flat mirror, the longer that is, the more precise you can be with your measurement. So yeah, I think that's something I should think about doing because I'm just curious about that. I've heard a few stories about that, and uh, um, uh, yeah, I don't know. Um, yeah, and our instro, hey, nice to see you in the chat. I'm looking at your comments there, and well, that's what I mean though, is that the velocity of light is a decreed, the velocity of light in a vacuum, right, is a decreed number. right? It is said that it's this. And what I'm saying is that measurements of the velocity of light in vacuum, um, I've heard stories about it changing over time, um, uh, with no discernible patterns that I'm aware of. And I just like to investigate that a little bit more because, if the velocity of light by measurement is changing, then well, what's going on there, and why would that kind of information be suppressed? Because that's pretty interesting, right? I mean, if the velocity of light is changing, um, then it's like, okay, well, why is it changing? And if we can find either, at the weakest, some kind of correlation, and at the strongest, some kind of causation, that would be very cool. And but that's one of those things, the velocity of light is one of those things, right, that you can't touch because it's been decreed that it is this value, and it is a constant, and by definition a constant does not change. Um, so so uh, um, yeah, I just think that it needs to be investigated. Uh, I I find that a very interesting thing. And as I said, the experimental setup for that really isn't a big deal. I mean, you have to be able to measure distances um, pretty well, and you actually need one other piece of equipment, and that is a some kind of like a pulse counter, so you can measure the frequency of the rotation, or some kind of a device that actually shows it on a screen, right? Because you need to know um, what the rotational frequency is, um, and you need to know all these distances. Uh, but all that's pretty simple, and then just a regular old red laser will do, or a green one. Doesn't matter what it is, right? Light is light. Supposedly, it moves at a constant speed, uh, but yeah, it would be pretty easy to set that up. And as I said, if I had that set up here, I would make a measurement. I would want to, at least every month, maybe even every week. You know, every week, uh, make a measurement of of the velocity of light, measure all my errors, all of that. You know, um, because if there are significant differences in my measurements with the same instrumentation, the same basic experimental setup, right? Then if it's changing, what's going on, right? Um, uh, yeah, yeah. Well, that's just it. So yeah, I want to I probably need to investigate this a little bit more. I think um, I think one of the places that I've heard about that was a fellow named Rupert Sheldrake. Have you ever heard of Rupert? Rupert's a pretty interesting guy. He's got an interesting perspective on things. I encourage you to check him out. Check him out. He wrote a book, which I think published in the United States was called. Um, wow, I don't know. I think in Europe it was called The Science Delusion. I don't remember. Don't remember now. But anyway, I think if you go to like sheldrake.com, I'm just gonna do it here without you looking. Sheldrake. think it's sheldrake.com. Nope. Is it Rupert Sheldrake.com? Yeah, I'll get you that in a second. Nope, that's not it either. Sheldrake. Well, let's just do this. We'll Google him. So yeah, I think it's one L. I think it's only one L, Atta. I'm now going to Rupert Sheldrake. Sheldrake.org. That's what it is. Okay, let's. I didn't mean to diverge like this, but let's just. I like to share with you things that I find out about, and as I said, I I like to keep an open mind to lots of things, and this guy isn't really far off, right? Let's see. The book that I'm talking about is called, Science. It's called Science Set Free. I saw it here. Uh, Science Set Free. So, anyway, check him out. Interesting, interesting guy. He's a biologist, but he's really uh, one of the things that he's doing is he's questioning um, the current scientific um, culture and wondering, if we are a little too dogmatic and a little too strict and uh, you know um, maybe not curious enough to it's all too easy to sort of knock down the strange new idea, um, and it's extremely easy these days with this, right? Um, so as I said, I put on my skeptic's hat and my open-minded hat at the same time, um, with stuff like that. Um, so yeah, let me put the whoop. I gotta do it over here. So I'll put it in the chat here. So it's www.sheldrake.org, just like that. So yeah, pretty interesting, and I think he's at least one of the sources that I've heard about this changing speed of light thing. Um, uh, so yeah, that makes me extremely curious, and it makes me want to do it. And I'm I'm wondering if anybody is. Um, I'm wondering if there's somebody out there, right, who, has this OCD thing, right, where they have to measure the speed of light like every day, right, or every week or every month, whatever it is, right, or on the full moon, have to measure the speed of light, uh, and they've been manic about it, and they've been doing it for the past 30 years. They have 30 years worth of data, and yeah, I like that. And yes, I ordered the webcam. Thank you. Yeah, so I got a notice this afternoon that it was shipped. So the little thing says between the 11th and the 19th. So yeah, maybe next week, something like that. So yeah, I finally it's all I had to do was push the button, and it's like, okay, I'm going to push the button. Um, yes, that's absolutely true. That uh, the speed of light does change depending on what medium the light is in, and we see that effect, and we call it diffraction. Uh, yeah, turns light into rainbows and all of that. So yeah, and actually, refraction is also involved in that, right? That's internal, changing the path of light because the light is going through a different kind of medium, so it changes speed. But yeah, I'm talking about speed of light as measured in a vacuum. Um, One can assume, I guess, pretty reasonably that if the velocity of light was changing in a vacuum, right, over time, then it would probably be changing in these other materials as well. Maybe proportionally, maybe not. It depends on what the cause is, right? Yeah, my understanding, Arnstro, is that the changes observed were pretty significant, right? Like no, this is not some kind of measurement error or systematic thing. This is like this changed in a significant way, a noticeable, significant way. So yeah, but we want to make those error bars as small as we can anyway. Anyway, so that's why I say, in anything I would do, I would want to use a huge baseline, right? Have it several hundred feet away, if possible. But keeping everything aligned and everything, I mean, it's something to think about. Something to think about that I should probably do. It'd be pretty simple. So all I need is a couple mirrors. I've got a laser. I would need a rotating mirror and as I said, a frequency counter and a couple of mirrors, a frequency counter, and and a rotating platform that I can change the speed on. I totally agree too. I have not I've not seen any of that data. I've just heard stories uh, from Rupert, right? So I mean, it's probably something that can be looked up, right? So yeah, maybe I should do that. All right, well, cool. Let's see. I'm trying to think if there was anything else. So yeah, I got the camera. It's on its way. I don't know if there's going to be any kind of improvement in the quality of this or not. I really don't know. It's also a 720p. Um, so I think that's what this is. I think. So is it going to be any better? I don't know. I don't know. I would like a wider field of view, and it has an internal mic. I think this one does, but for some reason, well, maybe it doesn't. Yeah, maybe it doesn't. I'm not sure. This this one, the C615, does have a mic, so I will definitely give that a try. But it's gonna, as I said, I mean, it's going to pick up all the background sounds, like the sound of this fan, which I don't think you can hear at all with this mic. Um, and it's gonna, pick up all the reverb in the room too, which I don't think you're getting very much of here. I think what you're getting is a pretty clean signals. Um, uh, oh yeah. No, look, our intro. This is a circle of friends. We're having a conversation. So you know, uh, sometimes conversations can get heated, right? But no, not in this case at all. No, not at all. Try to be as friendly as we possibly can here. Yeah, I uh, I don't know about the laser reflectors on the moon being a way to do that or not, because mm, there you're dealing with a moving target, something that's moving pretty substantially, right? So yeah, mic stand, mic stand. I could get a mic stand. I could. I forgot about that. Uncle Bill, you are saving the day again. So yeah, I can get a mic stand. That would be awesome, because having to, having to hold this just makes me have to work. I don't want to work. Hmm. And I'm out. I think that means it's time to go. All right, friends. I think we're gonna get out of here for today. So yeah, this is kind of a special day, right? It's 7/7 today. It's 3:09 UTC on 7/7/18. So I remember 7/7/7 really well, really well, because it was on that day that I resigned from a job that had gone a little bit foul, and so I decided to resign on 7/7/7. Now, seven is a uh, I I sort of have a interesting relationship with numbers. They actually um, uh, give me a sort of a sensation, and seven uh, is a really bright, like a bright white uh, number. It's a prime, right? Which I like all the primes anyway. They're really bright. But the seven is probably, got to say, in terms of base 10 digits, I think out of the 10 that are available, seven is pretty much my favorite one. Seven, and then three. Yeah, three is pretty cool too. Anyway, so yeah, today, at least UTC time, it is again 7/7. So yeah, that was wow, that was 11 years ago. Pretty amazing. Pretty amazing. I am getting old. All right, I'm going to get out of here for now. So take care, everybody. I will see you again on the spin tomorrow. If you haven't subscribed yet, make sure to do so. If you like this kind of stuff, if you can hit the notifications and know exactly when I'm going live, hit the thumbs up if you haven't already, or the thumbs down if you so desire. Share this around, right? We're trying to find our core, our core circle of friends, sharing a common passion. Excuse me, a common passion for the science of astronomy, and just having a good time. Just forgetting about pretty much everything else, and focusing on the universe. All right. So take care, everybody. I will see you on the spin. Don't get dizzy. Don't get dizzy. It's a smooth ride. All right. Take care. Bye.